This is John from caveofprogramming.com. In this tutorial we're going to take a look at animating colours. The reason that I want to do this here is because at the moment we've got a nice block of purple on our screen, and we've put together all the essential elements for rapidly updating the screen. We've got a loop that can do that. And it's I want to change the colours of the pixels as we go along. So we're going to end up with some particles kind of bouncing around the screen, which are going to slowly change colour. But it's a lot easier to see the colour of an entire block than it is of an individual pixel. So for that reason, I thought while we've got a block of colour on the screen, let's take a look at sorting out the colour change that we're ultimately going to apply to our particles. So at the moment we've got a purple screen with a single white pixel right in the center there, if you can see it. So I'm going to get rid of that white pixel, delete that, and I'm going to work on changing these colors that we fill the entire screen with. So to do this, let's pick one color to start with. Let's maybe animate let's say green. So let's set green to 255 and set the red and blue to 0 for the moment, and just check that that looks okay. And what I actually want to do is change the colours smoothly. Now the ideal thing to do here would be to look at an algorithm for mapping RGB, red, green, blue colours, to something like HSL, hue, saturation, lightness. The hue is the particular shade of colour, red or green or whatever. And if we had an algorithm that could take a number and turn it into a hue, we can cycle through all possible hues and see all the colours of the rainbow. But since that algorithm will be quite long and involved, I'm going to take a shortcut here. I'm going to animate all three colours. I'm going to make them smoothly wax and wane, like grow and fade, and I'm going to make them, all three colours, do that out of synchronization with each other, so that we end up with a range of different combinations. So to start with, the challenge is just to smoothly animate one colour, make it wax and wane, make it gradually increase to maximum intensity, and then slowly decrease to minimum, and to cycle through that. So to do that, I'm going to use a trigonometric function. I'm going to use sine. So to use the sine function, you need to include math.h up here, which is maybe already included in STL, but I'll include it explicitly. It's possible that this might just be called math on your system. On mine it's math.h. A lot of these .h suffixes were dropped from standard headers like IStream, for example. They're still header files, but the .h suffix was dropped to make it look nicer, basically, at some point. You might need to include using namespace standard as well to use functions from math.h. Now sine, I'm not going to get into the details of trigonometry, but we can think of sine as a function which takes a number and it maps that number. In other words, it returns a number in the range -1 to +1. So if we supply sine with an ever-increasing number, it will return to us a value in a range -1 to +1, and the value that it returns as we increase the argument that we supply to it will smoothly bounce up and down between -1 and +1, so there are no abrupt changes there. So what we want is to supply sine with some value that increases as the program continues to run. And to do that, we can use a function called SDL_get_ticks, and this returns the number of milliseconds since the program started. So let's say int elapsed equals SDL_get_ticks. And I'm going to supply that value to my sine function, and sine is going to return a value. Let's call this green. between -1 and +1. So we could just output that for the moment just to see what it looks like. So if I run this now and just let it run for a bit and then quit it, in the console here, oh yes, we're seeing zeros because I forgot, of course, that the return value is a double. It's no use using an int there. Let's try this again. So I'll run this, let it run for a bit, quit it, and then we can see that every time the loop's executed, we've supplied an increased value to sine, the number of milliseconds since the program started running, and sine has returned here a value in the range -1 to +1, which it's not easy to see here because quite a lot of milliseconds are passing in between each iteration of this loop, but it does actually range smoothly between -1 and +1. It changes gradually. Maybe we can see, maybe we can slow down the change if we multiply elapsed by some small number here, because here we're jumping quite a lot, like from -0.9 all the way up to 0.3, which is not a smooth change, because we're supplying a much bigger value to sine from one iteration of the loop to the next. So a lot of milliseconds passes between one iteration of this loop and the next iteration. Let's multiply elapsed by some small number like 0.001 and see what we've got then, see if the return value is appearing to change any smoother. So this looks a lot better. Now we can see that it is a smooth change. We've got 0.95, then 0.95, well it's 0.95, 0.96 basically here, 0.95, 0.94, 0.93, 0.935. So you see this value is smoothly changing it, and it will bounce up and down between that minimum and maximum value, -1 and +1. What we want it to do is bounce up and down between the minimum and maximum possible values of green, which will be 0 and 255 in decimal. So first of all, if we add 1 to sine, that will give us a value in the range 0 to 2. Let's run this again, quit it, and take a look. So now our values range from 0 all the way up to 2. We haven't got many values here, but it will in fact range from 0 up to 2. Now if we take that and multiply it by half of the maximum value that we want it to reach, half of 255 I guess would be 127.5, but let's maybe multiply it by 128 and see what that looks like. So if I run this, just sort of leave it for a bit and then quit and take a look. So now hopefully the maximum value of this will be 255 point something. So to actually get the value 2.0 from sine, we'd have to supply it with exactly well, for sine it will be exactly pi over 2, I think that's right, or 3 times pi divided by 2, if I remember my trigonometry correctly here. Sine of 90 degrees is 1, so therefore I think I'm right in saying that. Well, we could try that actually. We could use we could supply this with math dot. Actually, I think there's a constant in math called m_pi. Let's divide that by 2. See if that runs. I'm not sure if I remember this correctly. So now, if we look at that, yeah, we get 256. But if we're supplying this not with exactly pi over 2, pi is 3.1.141592, etc. If we don't supply it with exactly pi ever, then we're not going to get exactly, it's not going to return exactly 1 ever. So it's always going to be some number that's slightly less than 1. So for that reason, I think this would never give us quite 256. It would always give us 255 point something. We don't want it to be 256 because that's outside the maximum range of green. So let's maybe try, we could try running it for a bit and getting the maximum value of green here just to see what it is. Let's change green now to an int so we can discard the like the numbers after the decimal point here. And let's declare a variable here, max, which I'll set equal to a low number like 0. And let's say inside the loop, if green is greater than max, then max equals green. With an if statement, usually use brackets, but if you've only got one line that you want to execute after the if, you can omit the brackets. But a common source of errors is to omit the brackets in if, and then to imagine that stuff after the if statement will also be included within the code block of the if statement. But an if without brackets, without the curly brackets, will only apply to the next line. So for that reason I usually put the brackets in, but let's just try this temporarily. And at the end, let's say after the loop finishes, let's say cout max and max. So this, I wanted to show you this because this is a really handy thing to do to get you can get a minimum value in a similar way as well of a variable. If you're doing animation, often you want to know what the minimum and maximum values of some number are. So let's leave it just for a little while and then quit it and take a look. So the maximum value is 255. What I'm going to do is, as an extra kind of bit of security here, let's remove this max thing, and I'll remove the output of green, and we'll remove this and this. I'm going to store the green in an unsigned char. So if this did happen to return 256, then it would simply map to some number within the range 0 to 255, because that's all an unsigned char can store. You would see like a sudden jump in the colour, which doesn't matter too much for this program. It's not like we're animating a figure on the screen with this. So I think that's all right. But if we do see sudden jumps in our colour, then we might suspect that somehow we've supplied a value to sign here that actually is causing it to produce the maximum possible value of 256, and then maybe we'd want to make this 127.5 or something just to ensure that can't happen. But I think this is probably all right. Now let's supply green in here. And by the way, C++ doesn't seem to care if it doesn't care about the fact that I've got a double here and an unsigned char here. It just puts the value into the unsigned char, whatever part of it fits, which should be all of it in this case, and discards the stuff after the decimal point. But if you want to make it clear that you're doing a cast, you can put in brackets before the value here, and I'll surround the whole thing with brackets as well, unsigned char, just to make it clear what you're doing here. Now let's run this and see how it looks. Now I suspect on your video this might look quite rubbish because the video may not reproduce colours very accurately, but I can see here on my computer that we're getting a really nice, very smooth change, as smooth as you can with 256 possible values, from black all the way up to maximum green intensity and then down again and then up again. Sort of looks like it's breathing. It's a little bit fast though, so I'm going to change this a little bit, put an extra naught in there, and then let's take another look at it. Let's run this. There we go. Now it's changing very, very slowly, quite slowly, from black up to maximum green, then down slowly again to black, and then up again, and so on. So that's why I use the sine function, because it can produce this nice, smooth looking sort of change. At times, at the moment, I can barely discern it changing, but if I watch for a bit longer, I can see that it is in fact changing. It might be too slow, but I'll see. Let's change, now let's change red and green in the same way. So I'm going to copy this, paste a couple in, and let's have a red and red and blue. let's have a red and blue. And I'd like these colours to change. I want to combine them all, but I want them to change at different rates. So let's change this constant here. Let's have this 0.002 and this 0.003, just to make them change out of synchronization, so that when we combine them, we should get various hues of the different colours. And I'm going to put red in here and blue in here. And let's run that and see how that looks. Should be interesting. So now it's sort of grey, purplish. Again, probably looks a bit rubbish on your video, but here, well, it's sort of pink and now it's sort of yellowish. Now we're going through to full yellow. Now green and sort of, yeah, it's really sort of darkish green. Now it's getting a bit blue. I think that looks quite nice, except that I'm not wild about this pink colour at the beginning. Maybe it's alright. Well, we could try and see how it looks. You could also use a cosine function, which is exactly the same, except that cosine will start for a value of 0. It starts at its maximum value of 1. I'm just curious how that would affect it. Now it starts off with a sort of greenish colour. Let's maybe, well, you could play around with this indefinitely, really. So I'll leave you to investigate that as you wish. I think the sign there wasn't bad. Let's stick with that. See how that looks. So now we've got a nice colour changing algorithm, and I'm ultimately going to apply that to animated particles that are going to bounce around my screen. But I'll leave it there for this tutorial. So as always, I'd recommend having a go at that for yourself and get it working. And the great thing about this is now we're starting to get into territory where it sort of encourages you to play around with it, encourages you to try different values in here, try try cosine if you like, and you can get creative, and anything that springs to mind, any way that you can think of to change the colours that might be interesting, you can try them. And it's well worth having a play around with this and seeing what results you can get. So in the next tutorial, I'm not sure what we'll do. Possibly we'll start looking at particles because we've got to get around to that soon. So until next time, happy coding.